So some of the consequences of light travel time is, like I talked about, the fact that light is finite means that when you are on Earth and you try to talk to someone on the moon, it takes about 1.5 seconds for the radio signal, which travels at the speed of light, to reach someone on the moon, which means it'll take about 3 seconds for you to get a message back if they're talking to you right away. Okay, when you go to Mars, it takes about 7 minutes for a signal to get to Mars. So it takes about 15 minutes for a signal to go there and come back. So this is a challenge for rovers. You got little robots up on Mars, driving around. Scientist is watching what they're doing, making sure they're not going to drive off a cliff or something. So they're going to send instructions. They're going to send it. It's going to take 7 minutes to download over to Mars, and then the rover is going to do something, and then you'll get a signal 7 minutes after that, so about 15 minutes after you send it, that you're going to see the rover doing what you asked it to do. This is a big deal for missions that land on Mars, because everything has to be automated. You can't land something, you can't real-time land a robot on Mars. You can't control it from Earth. It has to automatically do everything, because you can't respond. It takes 7 minutes for you to see, it takes 15 minutes for you to get the signal back. So you can't, we need to change that. It's too late, it already crashed on the surface. Okay, so those are the consequences of light travel time. And then you go to something the size of our galaxy, which is 100,000 light years across, which means a star over here starts watching episodes of Seinfeld, which is us maybe, and then a planet over here also has life. It's going to take 100,000 years for those episodes of Seinfeld to get across our galaxy and for this planet to know what's going on. So this is a little bit crazy. And then Andromeda Galaxy is our closest neighboring galaxy, which is 2.4 million light years away, which means it takes 2.4 million years for those episodes of Seinfeld to reach Andromeda. So this is the consequences of light travel time. We see the universe as it was. Okay, we do not see the universe when we look out into space as it is. We see it as it was, and the further we look out into space, the further back in time we see that area of space. So you imagine you are here on Earth, and then you've got another planet in another solar system. Light, we see an image of that planet, and I can imagine here's that planet, and then that image of it, this is the picture, finally reaching Earth. We see it, but as the light is traveling to us, life is evolving on this planet, a lot of stuff is happening, so there's kind of a delay in information. We're not getting it, and the further away the object is, the less the further back in time we're seeing it. So we see Andromeda Galaxy, our neighboring galaxy, we don't see it as it is right now. We see it as it was 2.4 million years ago. So this is a limitation in our ability to understand what's going on in the universe today, but it allows us to study the evolution of the universe throughout history, because when we look really far back in time, it's like looking through layers of soil and seeing, dinosaurs and fossils and going back in time on Earth. We look back in time in space, we see nice young galaxies nearby us, and as we look further out, we see we see really young galaxies. We see them when they were babies. We don't see them as they are today. So we get to see the baby pictures of the universe when we look at the edge of space. So that's the consequence of the light travel time. We don't see the universe as it is. We see the universe as it was. And the further we look out into space, the further back in time we are able to see, and the younger the universe we get to study, until we look at the very edge of space and it's a boiling pot of stew, the Big Bang, the beginning of the universe. So we're going to talk about all this in probably the end of the chapters. The last few chapters we talk about the edge of space and the cosmic background radiation and the Big Bang hypothesis. So I can't wait to tell you about that. It's going to be great.